Okay, I got a lot of material to go over, so we're starting. I don't care what they say. So I was just in a super session, and I had to go through this stuff in like 10 minutes, so I will try to go a little slower. Who we are? We are FINRA, the Financial Industry Regulatory Authority, and our job is to regulate all of the broker-dealers who are making trades in the U.S. Stock markets. And we do this by setting the rules and enforcing that they follow the rules. But that part of the business, small data. The part of the business that kind of pushed us into the cloud had to do with the 6 billion trades that get done on the stock markets every day. We have to pull that in, and we have to run surveillance on that to make sure people aren't trying to manipulate the markets. And I say 6 billion, but it might be 6 billion today. Volumes may go down tomorrow. And all of the broker-dealers may not send their data in. So now I have to run yesterday's patterns again because I now get this late data. So now I'm dealing with 12 billion. And then maybe 3 days ago, somebody's now sending their data in. Now I have to run it again. And this growth means that of compute and storage was just way, way more than one company would be able to do on-prem. So AWS, or actually cloud computing made sense, and AWS is our partner. Okay, so to figure out now that you're in the cloud, the cat's out of the bag, you now have to be able to monitor this. We've got to do just a little bit of history about where we were so we can see about what we need to do. So we had cyclic processes, right? So I would do a POC, I get my budget together, we figure out how much hardware, we get it approved. That's all backloaded. We know how many headcount it is. So actually, project management is really not that difficult in an on-prem world whenever things follow this thing. Of course, skunk works come up all the time. But everybody had defined roles, right? So coders coded, administrators did their administration, managers managed. And those coders, all they want to do is start coding, and that box hits the platform, or it needs to be built. And these administrators would ask these annoying questions like, what's that server for? Because they have to figure out what network to put it on. DBAs would ask questions, and it all took time. And they couldn't really code. And they really wanted to code because that's what they do. But Agile and cloud came into view. And now they don't have to wait for us. They just point and click. And immediately a box comes up. And now I need to be able to manage that. Because I don't know about your developers, but I started out in development, and I guarantee you I didn't know anything about security. I didn't know much about networking. I didn't know much about DBAs. It took several years through my career to be really strong in those fields. But you think the developers do? So when you have to figure out what network, or what subnet that a device lives on, you know how you do it in AWS? It's a drop-down. So I'll just pick this one. So I worked at FINRA for 10 years, and for 9.5 of those, a data source never got put on an external subnet. 6 months into it, it did happen. We caught it, no data was there, but it got put on. It's just because a developer is not going to be a person who's going to be able to manage that and understand how that is. So you're going to have to be on top of it. So they are not only making security decisions, they're making financial decisions. So if you're a developer and you want to start up a box, which one do you start? I'll take the biggest one. Click, M4X, whatever. It's yours. But that costs money. So they're actually making financial decisions for your company every time they point and click. And they're making architectural decisions. So did you need that M4X1 large, or could you have used the micro? Whatever the situation is. Are they making those decisions rationally? Is there thought behind it? Are we worrying about the cost? So the last piece here has to do with hacking. So that kind of redefined how it is for security. And what did it do? We said, hey, we just can't just put code there. We need to actually train the developers so that they can actually bake in security. And so whenever we did that, we made a conscious decision, this was on-prem, that we really need to train the developers to understand about security. And until we hit these other areas, we're going to have gaps. And you're going to have to manage those gaps. Well, maybe you won't have to, but I have to manage those gaps, and we're going to talk about how we do that. See, there's some of the challenges. Stan Lee. So I don't know why they always give like the quotes to the person. It's like, you know, like I could have been a contender speech. They never give the writer. It's always Marlon Brando. So I give Stan Lee some credit. Okay, so these are some of the things we have to deal with on security. Did they put the right firewall rules on? Did they put it on the right subnet? Did they stay within budget? So all these things we have to now deal with in a distributed environment. It's not a centralized environment anymore. So are these new problems? Nope. It's just a different environment to deal with them. And the Henry Ford approach to walking this through is not going to make it in an agile cloud environment. Okay, so we're going to talk a little bit about security. It's a big field, so I'm just going to try to trim it down, and I'm going to deal with identity and access management, and we'll talk about why. So AWS has this thing called a responsibility model, and those are their quotes up there. And I thought about it left, right. I don't really know how to explain it except to say they're really transparent about everything they do. Anything else you want is your responsibility. And that's what you have to try to decide, because you're not going to be able to do everything. You're going to have to figure out what's important to you and what you can do and what you can't do. And if you need a certain security feature, then you're responsible for it, unless AWS says that they'll do it. Now, they'll come up with lots of best practices, and they do for IAM as well. And I've listed a bunch of them here, and we're going to go through a few of these, but they'll be glad to give you best practices, and you're going to have to implement those. And you're going to have auditors come, and they're going to say, hey, did you implement this? Because they can download that best practice sheet just as well as you can. And so we're going to talk a little bit about how we leverage Splunk to be able to address these, because these are actually good things. It's not like we're doing it just to appease an auditor, although we have to do that quite often. Okay, so the first one is lock away your root account. So for us, we don't allow any console access, and you don't create any keys, right? We don't want any access keys. That's what AWS says, and that should be done, because you don't really, they say give you the root account, now hide it away. So IAM, that service is in AWS, and AWS has CloudTrail, and CloudTrail will actually log every one of your IAM events. And Splunk has an app, and that app makes it pretty much trivial to be able to collect those CloudTrail logs. If you are in AWS and you're not running CloudTrail, I would suggest that you do that. And so now we can collect those, and it's 1, 2, 3. Yep, there's a little command. It'll just go up and tell me if anybody created an access key for my root account. Piece of cake. Next one. There it is. I now know if anybody's logged in with the root account on the console. Piece of cake. That's it. Goodbye, auditor. Here it is. 1, 2, 3. Everything's not that easy. So I wish it was. Life would be wonderful. So credentials and rotation. This becomes a little hairy. You're going to have to decide as a company how you want to do this. So, but you might do it on a time base. I want to rotate my credentials on a once a month, whatever your time based is. Another one is you might want to tie it into Active Directory, so if anybody leaves a certain group, that I know that I actually want to rotate those keys, because maybe that person left the company and he's not real happy, or she's real happy, and they can easily go to walk to the nearest cafe and connect to the internet, and those keys will be good. So you're going to have to be able to manage those. And we do that in AWS. And we need not just the CloudTrail logs, but we also need a little bit of Boto code. So if you've never worked with it, I have a little sample here. It's easy to do this, but you're going to want a baseline. And you're going to want to pull some IAM information. It comes in JSON, or you could put it in CSV, which is natively will go right into Splunk. And now you'll be able to baseline and then use CloudTrail as a transaction log. So now I can go and check those things out. And now I also pull in my Active Directory data. Now I can correlate that. Anybody who's left this group, I now get some knowledge of that. I can go over and say which service account needs to have their keys rotated. And this is not the code that we currently use, but I just put a little teeny piece here just to see. It's really simple. So this is, if you know Python at all, you just compile these libraries. And in order to connect and use the APIs inside of AWS, it's easy to grab this information, and it's really easy to get it into Splunk. So this one over here just picks up all of the users to see the last time they changed their password. And if you actually have user accounts that can use passwords, we don't use that. We use the federated services, so no user ever actually logs on. But if you have that, you might want to, I don't know what your password rotation policy is, but it's easy to be able to grab that information and then adhere to your policy. Okay, so this is the fun one, grant lease privileges, right? So isn't that great? AWS says you should grant lease privileges. What does that mean, you know? What does that mean, grant lease privileges? That's the hard part. And this is where you need to actually integrate this into your corporation. So, and this is the hard part, is you got to get these teams together, and you have to actually decide what it is roles are allowed to do and which roles they're not allowed to do. And that takes some time. And we do that. We got these groups together. We come up, I just put a little sample role there, and I say, hey, these are the APIs, the ones they're allowed to do, the ones they're not allowed to do, the ones we don't care. And we put that into a version control system. So that's the gold source. And now we just run that little Boto code, and we go out there, and we run this, and we baseline it, and we come up and we say, are we adhering to the policies that we have in our gold source? And we do that once a week. During the week, we get CloudTrail. The CloudTrail log will come in, and if somebody did a put policy or a delete policy, we know that role's security position may have changed, and it automatically reruns the compliance, puts it out, sets up alerts. So I can now tell my auditor that, now maybe this information isn't as stringent as it needs to be, but I can at least tell you with 100% confidence that I'm following what that team or what this group over here decided was allowable and not allowable for the different roles. And then, once the data's there, you can just, this is where you get efficiency and really quick time. So we can just sit there and build these dashboards, and they take almost no time at all. And we do that all around IAM, but it's not just IAM. So tagging compliance. So we'll talk a little bit about this when we get to the next section, but if you have user-based tagging and you're expecting your teams to add it, if you think that's going to always happen, forget it, because developers have other things to do than to type those in. But you need to be able to run compliance on that and get that. But it's really important if you're going to do billing, and we'll talk about that. Security groups, logging, all this stuff we're able to run compliance on to make sure that they're adhering to it. Now, the nice thing about Boto and how easy it is to write that code and get it into Splunk is this isn't really heavyweight. And the reason we like that is AWS will come up with new features. Splunk comes up with a new AWS app, so I'm on the beta site, so I'm getting into VPC flow logs, so that's really cool. If you haven't seen that yet, it's really cool. Config is in there. So you'll supplant some of the stuff that you built. So you don't really want to put a lot of overhead and a lot of money into figuring out how you're going to collect this data from Boto. So something lightweight works really well because AWS is always coming up with new features. They changed the format. Okay, that's good. Okay. Wonder what happened. Okay, we're going to talk about now project management, so cost savings. And this is really, really important. I was talking to Praveen in my last session, and he said that they had a panel discussion, and somebody said, do customers really, do they really care about cost management in the cloud? And it's all those little numbers that say, like 0.06 per hour and all that stuff. It just gives that really good feeling, right? But I made the analogy of Neil Young singing "Rust Never Sleeps," and it's the same thing with AWS and their billing app. It never sleeps. So you click something, man, that thing works overtime. So what we were doing was we had these quarterly reviews. That's what we have today. So actually every month I'll get some spreadsheet. Maybe I'll open it up, maybe I won't. And then a guy named Dan Dan comes over, he visits me, we talk. He says, do you have any unexpected costs? And then we talk about it, have a cup of coffee. Everything's good because everything was backloaded, right? I already had all my hardware costs and everything. I wait a quarter today, and I may have some developers that are going to put me into a really uncompromising discussion with my boss because they are pointing and clicking. And let me tell you, they go home on the weekend and they leave it up, that AWS app keeps running. So you really, really need to get that. So what do I do for project management today? Do I just hand the 10 million lines into the report over to the project manager and say, here, go figure out where your costs are? Because that's how many lines we had last month in our bill. 10 million lines. Nothing for Splunk, but very easy there. So I need to be able to separate this out. And I need to be able to have managers focus on what they care about. Am I under budget? Where are my costs going? And who's spending them? And I can do that really easily with Splunk. And it also provides such transparency that it makes it easier then for them to be able to drill down and solve problems. And we'll see an example of that. And so this was actually being done manually, so that somebody was bringing this 10 million lines, they were bringing it in maybe once a week, and it was a manual process. We now bring this data in much, much quicker. So we had to decide what we wanted to do. And what we said was, hey, let's use Splunk because it can collect data really easy. It can do an analysis really easy. And it has a great visualization tool to be able to push it out. So we said, Splunk sounds like a winner. We could not use the AWS billing app. So we wanted the resource with tags billing record. I don't know if you're familiar with that, but that's the one we really needed. And they pull it in after it becomes outside of, it's estimated. So they keep putting data in and it's estimated. And then the following month it becomes your real bill. And that's when Splunk grabs it. Well, we didn't care if it was estimated or not. It was better than anything. So we now pull the data in. It gets updated a few times a day. And we just keep pulling that data in. And so now project managers have up to the AWS's ability to deliver that data to us. They now have that information. What else? Okay, so then we needed to enrich the data. So now if I want to make this viable to be able to answer those questions, I needed to know the project codes because I need to know which records to give to who. Forecast projections, I got to know what you're allowed to spend before I can tell you if you're over or you're under. And there's billing adjustments. So I don't know if anybody's read about reserved instances, but it's like a big long thing, and it winds up that for an instance class, AWS doesn't care who they bill it to. Whoever the first person to use it is winds up getting charged that reduced rate. So we need to be able to switch that around and make sure that the right project gets the credit for that reduced cost. So we put that in, piece of cake, and then we have to build the interface. If you like pictures, that's what it looks like. Piece of cake, right? The big thing is that app over there. And that's what it looks like. Just a simple little app that people can now find out exactly where their projects are. Let me tell you, this thing has taken off like you can't believe. So let's now sit down and look at a little bit of this. If I look over here at the top left, I now have a stacked bar that shows me the services for each day that I spent for that project. And I can also look at that blue line. That blue line is what I'm allowed to spend, or what my forecast is on an average. And if I look over to the right, I see it by SDLC, or System Development Lifecycle. So a project manager can go look at this and at any point in time know where his money is going and exactly which service. And does it make the smell test? Yes.
Question.
Yes.
Is there a drop down or something, or a filter
that's used to? Yeah, you can't see it up there, but to get which project it is, and then you can go back months and all that other stuff. Absolutely. Yeah, absolutely. So now that you have this, and below is just the accumulation, right? So now I can see where it is. And did we have impact? Absolutely we had impact, because we implemented this thing right about here. Right there, that project was never below their forecast model. But now they have to go and they meet, so Market Reg gets together and they go through this one by one. And who wants to go up to their senior vice president and be above that line? And now he wants plans on how you're going to get below that line. And immediately, you could see, we had big impact. You see all the numbers below that blue line now? That's good. That means I get a bigger bonus because the pool's, maybe not. Okay. If you are right-brained, we'll give you this in numeric format. Some people like that better. I don't know. But it's there. And it will actually cost it out. And now you can start looking at numbers. And it will end up telling you, if you keep on the same path, how much over budget you'll be by the end of the month or not. Okay, so impact, yes. So it allowed, as I said, managers to be able to focus on some really easy things to reduce costs and to be able to have policy. And one of the easiest ones was shutting devices down on weekends, especially in development, that you weren't going to run anyway. So why not shut them down? Why should you pay those compute costs? And that's why if you look back here, see those little empty ones that go way down? Those were our weekends. So all of a sudden they go, hey, we need to start shutting this stuff down on weekends because nobody's messing with it anyway. And AWS never sleeps. So if you keep it up, that'll be it. Storage. You just write it out there in S3, and then you forget about it. AWS doesn't forget about it, and we had lots of projects that were putting petabytes of data out into S3, and they didn't really need it anymore. They didn't have plans to actually roll that data off, and this showed it really easily. It also allowed these teams to decide which projects were over budget the most, so they could get the most resources on how they were going to do it, and look at which services were getting the most spending. So could we come up with better policy on how to use those services so that we could save money? So what was the results? 13.5% reduction in our line items. I wish I could tell you how much we saved. It is not insignificant, but our line items, our bills, remember I said there was 10 million? We cut 13.5 the first month that this came into play. If there's no line items, it doesn't necessarily equate, but definitely it means that we're started to bring down the cost. And I brought up the instance, there is one application was 210% over budget. And this month they're going to be $500 and some under budget. First time they're under budget since it went live. And magically it happened whenever we did whenever we put this app out. Now it's transparent. Now your other peers are seeing this when you go to those meetings. There's nothing like an old-fashioned witch burning to get everybody going, right? Okay, maybe not that. And then they can use this information for feedback and control systems. So how can we then take that information and bring the forecast line down? Okay, you made that one. Now bring it down, right? How do we do that better? Now they can do that. Futures, users want shorter cycles. They want that data more. We've had some instances where somebody picks the wrong thing and prices go up. Do we have to wait a day for that? It's AWS. I can't make it go any quicker until they give it to us. Back tagging. So somebody starts up a instance, and then 15 days into the cycle, they decide to finally put the right project or put the project code on. Well, AWS does not go back and reset those tags. We can do that on the processing, and that's what we're working on to be able to get better. Free rider services. Now we're trying to figure out. AWS does not allow tagging for every single service, SNS, SQS, those kind of things. So we're trying to figure out how we can better deal that out so that we can figure out an a better way to do that. So, and better drill down analytics. So drill down analytics are really, really important. And I brought up the 6 billion transactions that we have to deal with anymore. And the question is let's say you do all these things and you're still over budget. Does that mean that that's it, the game's over, that's just the cost of doing work in AWS? Well, no, that's not just the cost. You can squeeze more out of it, but you have to do more analytics. And we did some really, really cool things in EMR that I think is really exciting. And Siddhartha is going to come up here and show you how we saved a ton of money in leveraging EMR.
Not really shut it down. Okay. So let's talk about how FINRA and why we actually started looking at EMR, because FINRA spends millions of dollars every year on EMR service, and that's one service which is like a black box, right? You start up a cluster, but then you don't really know what the underlying infrastructure is. So let's look at some of the challenges which we had to face to get a full transparency of the EMR service. Prioritized infrastructure as a service are not the same, right? Because you have less visibility and flexibility in a product as a service offering. And on a regular on-prem server, you just go into Splunk and say host is equal to star app star. Then you know what that instance is actually doing or what that host is actually doing. But how do you say that in EMR? The host name is IP-10.1.1.1. You don't really know what the host means, so you don't really know what the host is doing. Now to solve that, we actually started working on instance fingerprinting. And what we are trying to do in instance fingerprinting is to be able to identify what the node is, to find out the unique IDs for them, find the instance roles, what that instance is supposed to be doing, and then all the user-defined tags around that particular instance. Next comes data retention. Now, AWS has a service called CloudWatch, and they provide you the metrics for any EMR cluster you start up for 14 days. But then, hey, what if you want to go back 2 months and look at a cluster which actually has the same job which you're running today? Now, you can't really do that. Now, with Splunk, you could solve that because, hey, you can keep it forever if you want to, and if you have the money for that. And then collection delay. AWS takes about 15 minutes to actually send the data from an EMR system back into an S3 location where you can actually download it. But then you have to click through millions of tabs and all that. But then that delay is something which wasn't really acceptable to us, because our developers wanted to be able to see it real time, because it only takes, because we have jobs which run only for 30 minutes. So to fix that, what's the best way to do it? Is to install the agent actually into the EMR service and get it almost near real time. So this is how we do it. If you look at the diagram there, we have a few different components there. We have an S3 location, EMR, and then the components under EMR, and then a Splunk forwarder there. We basically store a BSX script in an S3 location. It's basically a bash shell execute script in an S3 location, and it has a few different components under it. The first thing is Splunk full-blown heavy forwarder RPM, so it's full Splunk enterprise license, and it's just a heavy forwarder. So we need to remember that we need to shut down the web service whenever you start that up. Otherwise, you'll have millions of EMR instances having web servers running everywhere. Deployment client.conf file to let it know where its deployment server is, so that it can go and get its respective apps, and then discovery strips. You see a small star there, it's basically like a condition. Discovery, we'll look about it in future slides on what we actually do with the discovery strips. Executing Bootstrap. It's like a regular installation of software in EMR. You create a Bootstrap action, a step function, and that's it. You specify where the S3 location is, and an EMR service will take care of it. Master code and task installations. It depends on what your choices are. Few apps wanted it, at least in FINRA, a few apps wanted it everywhere. Few apps wanted it only on master, wanted only on core tasks. So it completely depends upon how your app works and what your needs are. But yeah, you can actually pick on which type of instance node do you want to install that one as. And AWS was actually really supportive of this idea. We thought they'll be kinky about it. They'll be like, oh no, you can't really do that. But yeah, they were the ones who actually gave us all the log file locations on how do we actually do the fingerprinting concepts. Okay, so now we're coming back to the instance fingerprinting, and this is also the first part of discovery strips. So now AWS has a cool IP address, 169.254.169.254. That's the most easiest IP address I think they'll ever get. So they have a metadata service at that particular IP address where you can run your curl commands, and on each and every single instance when you run it, it'll give you that instance metadata information. So we are taking some of that information. We are using instance ID and the IP address because they are unique. They are the unique addresses for that particular instance. And then we try to grab the user-defined tags. We're using the EC2 describe tags command. It's basically an API command, and get all the user-defined tags. Now, these tags, AGS tag is something which is FINRA related. It's just application goal source, whatever the app name is. So you can have your own defined tags in your organization. But yeah, you need to get them defined beforehand so that people start using those tags in a proper place. SGLC, whatever the life cycle is for that particular cluster, we get that. And the next part is getting the cluster ready. Now you have all these instances, right? You have master, core, task. Now each cluster can have like hundreds or 150 nodes in there. Now what is the joining factor for them? Now you have cores, you have tasks, you have master. Now if you get the data as is into Splunk, it's basically like IP hyphen the IP address. And then how do you say that which particular master or which particular cluster does this belong to? So that was something which we had to fix. So we are extracting cluster ID information from jobflow.json file, and we also extract the role of that particular cluster or that particular instance from the same config file. Now we have all this information, right? We have the user-defined tags, we have unique IDs, we have cluster IDs and all that information. Now we need to let Splunk know about it, because Splunk has to use that data to create your structure, to create a host naming standards for you to be able to use it in real simple way. Now the second part of the discovery strip is to take all that information and to actually start updating the config file, and that's going to be your inputs.conf file. Now it looks a bit messy, but that's what it's going to be at the end of the day. So we are taking all that information, we are creating meta tags. As you see that, you're basically getting the full tags, whatever tag information you need, you just extract it, place it in here. Now, hey, we are doing all of this meta information anyways. So we thought, why not just we create a host naming standard for FINRA itself? So then we created that, which basically starts with EMR, and then whatever the app name is, then master or core or task role. E is basically the location. D is your SGLC lifecycle. And then comes your cluster ID, and then your IP address. Now you can see host is equal to star, cluster ID star, and that's it. It doesn't matter whether it's a core, task, master. You're joining all the instances in one single cluster ID name, because a developer is going to remember his cluster name. He's not going to remember what the IP address of this particular node is or this particular task is. So that's the most important factor. You need to extract the cluster ID and use that as a gluing factor for all the data to be able to say, okay, all this belongs to this particular cluster. Now, we have collected all this data, right? Now we need to make use of that particular information. So we built something called Cluster Analyzer. We're taking all that information and building a dashboard which basically looks on a cluster by cluster information. Now, as Gary showed, the previous building app will give you an overall view of how your project is working. But let's just say you have few clusters in your project, which doesn't matter, whatever you do, they're still way above what your estimates are. Now you can come here, pick up the cluster, and then you'll see the full information of how the cluster is actually working. The first row will actually give you those four single value panels will actually give you information of what the name is, what the start time is, what the end time is, and how many hours did actually AWS bill you for. The second row actually deals with two different components. The first one is the AWS Cloud Trail application, and the second one is AWS billing. So we get information on what type of instances it is, how many number of instances did that particular cluster use. And the second part actually deals with the full cost. The first panel will give you the total cost, EMR cost and non-EMR cost. And the last panel will give you itemized description of where you are spending in the non-EMR area. So it'll give you a list by list on, okay, did I spend money for S3, did I spend money for data transfers, things like those. Now this next highlighted part, it's basically Splunk for Next. We're just taking the same app which is on-prem, which everyone is familiar with, just putting it into the deployment server and just sending it out everywhere. And we're collecting all the data now from the CPU utilization, memory, VM stats, IO stats. But the most important things which we really care about, or which developers really care about, is CPU, memory, and how the HDFS utilization is. Then the last panel actually talks about all the jobs which are running on that particular cluster. Now I'm able to overlay jobs over my CPU or my memory metrics and say, okay, at this point of time, if my CPU is picking up, what are the jobs we're running? Now you can click on the job which was running and then drill down into all the job-specific logs and be able to see, okay, what was the function or what was the property of that particular job? What was it doing at that period of time? Or what was the step function which actually generated that particular log? Right, so now in the previous slide, you see the full picture of a cluster. Now, what do you analyze it, or how do you analyze it to bring your costs down? So let's look at the first strategy, EC2 provisioning savings. All right. So in this, the previous instance, actually, the previous cluster, we used M1X large instances with that set of configuration. It's 15 gigs of memory, and it's costing us 35 cents per hour. Now, if you look at the graph there, our memory utilization is really nothing. Right? It's hitting 30% of the max. But our CPUs are hitting 100%, at least in the beginning stages. So we probably need more CPU cycles in the beginning, but really lesser memory. So you can bring down the box. Actually, you can choose a different type of box, which is a C3X large instance, which has lesser memory, but it will give you more compute cycles and at a lesser price. That's 23% savings immediately. So you identify which particular instance or which particular instance type you should be using instead of just randomly picking anything. Now the resizing analysis. Now AWS gives you the ability to actually resize your cluster, and we are using that concept and trying to figure out what's my best scenario, or how many nodes do I need to be using all the time. The cluster provisioning summary will actually give you information from the CloudTrail, what type of instance it is and how many nodes are you starting up. And then you see the graphs there, utilize is less than 80% overall when you look at both memory and CPU. CPU after 90 minutes, it's done. It's really nothing. So what can we conclude from that? We can resize the cluster after 2 hours and just bring the number of nodes down. So let's look at the first scenario where all the 40 nodes are running all the time, the 4 hours. It's a simple formula. Number of instances, the price per instance multiplied by number of instances multiplied by number of hours. It's going to cost you $56 in the first scenario, right? Now look at the second scenario. You have all the nodes running in the first hour. You're bringing it down to 35 in the second hour because we are still using around 50 to 70% of our CPU. On third and fourth hour, you're basically putting it down by half. Now your total cost is only $40. You're saving 28% here. And that's significant when you actually multiply the number of times you're running. So now you're combining both of them. Now let's just say the combined analysis is you spend, the original cost is $56, but after combining them, which is, remember, we need to calculate it at 27 cents now because you're bringing in the provisioning analysis too. We are now using C3X large instances instead of using the M1X large instances. Now the cost is only $31. You're doing the job at 55% of the original cost. Now that's just only $25 which you have saved. And what can you buy with $25? Probably a Chromecast or since it's AWS, Fire Stick probably. But what if that job is running 5 times in a day? You'll save $125 in it. And what if that's running every single day in a week? That's $625. And when it runs on every week in a year, that's $32,000. Now you do that for one single cluster, and FINRA runs 7,000 clusters in a week. You do that for 20 clusters, you do the analysis for 20 clusters, you bring down the cost by almost $500,000. And that's a significant amount of money when you look at it in a year. And we haven't really affected any performance. It's just better provisioning strategy and how do you look at it. And now, okay, so we have collected all this information, but is it always about the cost and all that? Not really. Because once you have the agent in there, you can basically do anything. You can basically collect any information from it. So this is all Hadoop generated information. We collect the JHIST file, the job history file from EMR, And that's what we're trying to do. Like for a given cluster, give me all the steps which are running at that point of time. Give me all the map and reduce slots which are allocated or which are available to be allocated, and how many is that particular cluster using. And also give the elapsed and run times for them for that particular step functions, and then map and reduce statistics on how we are using that. Also, there's in the new version of Hadoop, which is I think it's V4 now. There's a concept of vCores and memory provisioning. We are also trying to look at that, like how is the memory and how are our compute cycles being provisioned to that. So this is our job history analysis, which we do on each and every single cluster. Features. Now, yes, we have a dashboard which you can look at, but hey, who's going to remember all the clusters and going to, or who remembers which ones to look at? So that's what we're trying to avoid now. We're trying to grade the clusters automatically to be able to say, okay, these clusters need to be resized, or grade them based upon their provisioning strategy and say, okay, this needs to be fixed. We are working closely with Splunk on ITSI integration in cloud. This ITSI works really well in an on-prem environment. What we are trying to do is take the exact same thing, put it on cloud, and then be able to generate over-provisioning or under-provisioning alerts to the people, whoever start the clusters, whoever are the owners, to let them know how their particular performance metrics are actually working on. Now we have looked at all the other data, right? We are doing the analysis based on cost, we are doing the analysis based on performance, but we can add some more different variables to that. So these are some of the other inputs which we are looking at. Size of data, which basically means the amount of data which that particular cluster is running through or pulling from S3. We are trying to determine cluster-based performance based upon that. And then how many number of steps or job functions it's actually running in a single period. Metrics correlation. The jobs thing is something which we have showed before. It's still in its infancy stages. But what we are trying to do is basically overlay all the Hadoop-based metrics upon the system metrics. Okay, like when a step is actually running through, be able to overlay my CPU or my memory metrics and say, okay, how is my system metrics related to the Hadoop metrics? That's something which we are trying to do and that's something which users want to see and say, okay, why is this step actually taking more CPU or more memory rather than this step? So they want to be able to identify that function. So that's what we are working on. That's something which we have done, and if you have any questions, we'll be really happy to talk. Thanks for coming in. Sure.